Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to focus on the idea of cumulative distribution function, CDF, for discrete case. Okay. Here, what we have is a discrete random variable x, and we would like to define the idea of distribution function, or also known as cumulative distribution of random variable x, which can be mathematically written as such. So what is the meaning of cumulative really? So cumulative is something that is increasing, so it will keep on increasing by successive additions. Okay, we just keep on adding according to a proper sequence of some sort, yeah. And the notation that we use here is capital F, so fx. Notice the difference between this one and probability mass function. Okay, so this is representing cumulative distribution, and if you have small fx, this one is probability mass function. Okay, and what is the meaning of this one? Well, this one is actually telling you to find what's the probability of random variable x taking a specific value, one specific value. Okay, now on the other hand, if you look at this mathematical definition given here, well, this is big fx, and it means finding the probability of our random variable x here taking a value that is less than or equal to this small x. So notice the difference here is in terms of this symbol that we use for cumulative distribution of x, and this one is just equal sign that is used in defining the probability mass function. Okay, now let me just give you an example here. If let's say we have x, okay, x is the value of random variables that may take values such as 0, 1, 2, 3, 4, 5 maybe. Okay, now if we talk about f3, so what is this? This is probability mass function. Then you are just considering the probability of x equals to 3. So maybe you're just considering this part only. Okay, so you're just considering the probability of our random variable taking the value of 3. Now, if we use a different notation, which is if we consider the cumulative distribution function, which is big F. So big F3, in other words, it means this thing over here, which is probability of getting random variable x being less than or equal to 3. So in this case, you are going to consider adding up. So when we talk about adding up, we use this symbol here. So this is a sigma, and it denotes the process of adding things up. So adding things up, so we're going to add the probability of observing 3, the probability of observing 2, and 1 and 0, because we're talking about the direction where x here is going to be less than or equal to 3. So when we talk about the process of adding things up, therefore the name here is called cumulative distribution, and it fits the definition given here. We can see that the value is going to be increased by successive addition. Okay, so that's the idea of CDF, cumulative distribution function. Now, to be a distribution function, this big Fx here must satisfy the following conditions. Now, the first one here is for this statement to be 0, the value of cumulative distribution function, if you approach negative infinity, is going to be 0, and this one is 1. And I think maybe this will better be explained through example later on, maybe. Okay, so maybe we can look at example later in order to understand what it means. Next, if A is less than B, then the cumulative function, distribution function for the value of A here is going to be less than or equal to this one for B. Basically, you can see it from, for example, from this. Okay, I can give you a simple example. If we consider the value of x 0, 1, 2, 3, 4, 5. Let's say this is the value of A, this is A, and this is the value of B. Okay, so clearly A is less than B, 1 is less than 4. So if I want to find the cumulative distribution for x equals less than or equal to 1, so I want to find F1. F1 will consider taking probability of x equals to 1 and also x equals to 0. So you're going to get some result here. Okay, now if you consider the next one here, B is a value that is bigger than A, so this is my value B. In this case, big F for here, cumulative distribution for x equals to 4 in this case. Well, you need to consider probability x equals to 4 plus probability x equals to 3 plus probability x is equal to 2 plus probability x equals to 1 plus probability x equals to 0. So you will see clearly that the result here is going to be bigger than, or maybe in certain circumstances, if the probability here 0 and 0 and 0, maybe the result is going to be similar to this one. So that's why we have this notation where FB here can become bigger than FA, and it can also be equal to FA. When is that possible equal to FA? Well, if this probability is 0, this probability is 0, this probability is 0, then the result for this one will be equal to F1, for example. Okay? Alright. Okay, we are going to look at this example here. Consider the following probability distribution of x, where x is the total number of heads obtained in 4 tosses of a balanced coin. And even though it doesn't say anything about whether this is discrete or continuous, but from this example you can tell that when you talk about total number of heads that you get during tossing a coin, definitely that is going to be a discrete case, because you can only get whole numbers, such as you can get 0 head, 1 head, 2 heads, 3 heads, and you can get all heads. Okay, so we stop at 4 because you only do it 4 times. Okay, and this is the probability values for each x, and so this table is an example of probability distribution that is expressed in terms of a table. Okay, how do we know that this is a probability distribution? Well, if it doesn't tell here, then you need to check. Okay, so what we can do is we can make sure that all these values are 0 and greater, 0 or greater than 0, between 0 and 1 basically. And when you add them up, the result should be equal to 1. And we can see it clearly that 1 plus 4, 5. This is going to be 11, 15, 16. So 16 over 16. So when you add all these values here, it will be equal to 1. Therefore, it satisfies the two conditions required for fx to be a probability distribution. Okay, the question is asking us to find distribution function of x. In other words, what is big F? Okay. All right. So here we're just going to construct a table because I think it's easier to do that. Well, I'm going to construct this table. We have x, and we've got values such as 0, 1, 2, 3, 4. And then for this one here is going to be big F. Okay, big F. All right, so what does it mean really? Now you can see that okay, when x is equal to 0, we've got f0 over here, which means we are looking for probability x less than or equal to 0. This is what it means when you talk about big F. Okay, we are using this notation, less than or equal to some number. So in this case, since 0 is the lowest number, this is actually equal to probability x equals to 0. What is probability x equals to 0? Is 1 over 16. So 1 over 16, and we can write down on this table 1 over 16. Okay, what about the next one? Well, if, for example, x is equal to 1, that means we are looking for BF 1, and it means finding probability our random variable x being less than or equal to 1. So less than or equal to 1, it means we are considering the value of 1 and also the value that is less than that, which is 0. And therefore, this is the same thing as adding up probability x equals to 1 plus probability x equals to 0. So add these two values up, we will get 5 over 16. Okay. Now for x equals to 2, so here we've got x equals to 2. So we are looking for this value, big F2. And this essentially means probability of random variable x taking the value of less than or equal to 2. And it means we are going to consider the value of 2, the value for x1, the value for x0. So in this direction. So we have x2 equals to 2 plus probability x equals to 1 plus probability x equals to 0. And add all these probabilities, we've got 11 over 16. And I'm sure you understand how we can proceed for the rest of the values here. Well, for x equals to 3, we're going to add everything here. Everything here, we have 4, 6, 10. So we got 15 over 16. And finally, for this one, x equals to 4, we're going to add all the probabilities from 4 to 0. So 1, 4, 5, 11, 15, 16 over 16. Okay, so that is the distribution function of x. Okay, let me just erase some part of this slide here. Oh no. Okay, hang on. Okay, right. Now the next question is asking you to find this value f1.7. Okay, so how we can do that is we can see that f1.7, what it means is probability x less than 1.7, but we don't have that values. Basically 1.7 doesn't exist here because we are talking about discrete case right now. Well, therefore or if you don't want to think about it in that manner, what I can suggest is maybe we can straight away consider this is equal to finding the value of f and 1, because 1.7 is in between 1 and 2. Okay, 1.7 is in between 1 and 2, sort of, but it doesn't reach 2 yet. So if it doesn't reach 2, you cannot consider this one. Okay, so you're going to consider f1, consider x equals to 1. So f1.7 is equal to finding the value of f1, and the result here is going to be 5/16. Okay, right, next is determine the value of 4.5. Well, you can see that 4.5 is somewhere here. So this is 4.5, and therefore this is can be obtained if we consider finding f4. So the next closest thing is 4. Similar to this one, this is 1.7. We're going downwards, so the next closest is x equals to 1. Therefore probability here is 5/16, the cumulative probability. And for this one, the answer is going to be equal to 1. Okay, that's it. Okay, there is also another way of writing down the distribution function of x, and this is how we can do it. Okay, you can see that we use the notation x being between two values. So 1/16 is referring to this part here. So it will be equal to 1/16 for x 0, exactly 0, or bigger than that. Okay, but less than 1. That means when it is 1, the value of that is 5/16. Okay, so if you're talking about so if the question is asking you for f1.7, you know that you can refer to this part here because the result is going to be 5/16 for x being equal to 1 and greater than 1. For example, 1.7 is greater than 1, yes, and all that value is before 2, because when it is 2, the result is going to be 11/16. So here 11/16 is for x equals 2 or greater than that and less than 3. Okay, so be careful with the use of the sign here, inequality sign. There are some without equal sign, some with equal sign, and so on. Okay, now another way of writing this is we can say that the result here is going to be 0 if x is less than 0, because the lowest value of x is 0. So if it is less than 0, and between negative infinity greater than negative infinity, then the result is going to be 0. So another way of writing this is in this manner. Okay, so if I ask you what is big F for negative 10, it's going to be 0. What is F for negative infinity? Now this is going to be 0. And this is related to, this is related to what we are seeing right here. And this one, well, for that one, for example, we can write this part here as for x greater than or equal to 4 and less than infinity. So the value is going to be equal to 1. So this statement here can be replaced with this notation, which is also correct. And for this statement here, it can also be replaced with this idea, this notation right there. So if I ask you what is the cumulative probability for 4.5 as given by this one, then we know the answer is going to be straightforward, equal to 1, because x here is already greater than 4. So if f 100, it is also equal to 1. If f infinity, then it is also equal to 1. Okay, right. Okay, let's move on to the next slide. Okay. Oh, hang on, before that, maybe we can try to represent the answer here in terms of using graph. Okay, so how can we graph distribution function of x? Okay, so here we've got the y-axis. This is bf. Okay, and maybe this is our x. Okay, this is 0.0, and we have values such as 1, 2, 3, 4, and that's all, I guess. Maybe you can write it in terms 5 and so on, it doesn't matter. Now here we've got maybe what scale should I use? Maybe this one is 2/16, 4/16, 6/16, 8, 2, 4, 6, 8, 10, 12, 14, 16. Okay, now based on our table here, when x is 0, the value of this is 1/16, or you can also refer to this statement. So 1/16 for x greater than or equal to 0 and less than 1. So how can we plot that? So therefore, this is how it's going to look like. So for x is 0 until 1, okay, the value is 1/16, which is maybe here. So this is 1. So we've used full circle and it goes in this direction. But here we use open circle because it doesn't include this point here. X is not included. You see? X less than 1, so it doesn't include 1, therefore we use the open circle for that. Now between 1 and 2, it's going to be 5/16, therefore between 1 and 2 here. We're going to consider between 1 and 2. 5 over 16 maybe somewhere here. And at this point, we're going to use full circle because you can see clearly that we have equal sign here, x greater than or equal to 1. Therefore, 1 is included. When 1 is included, we use open circle. So 5 over 16 until 2, and right here we are going to use, this is full circle and this is open circle, yeah? Next, between 2 and 3, 2 and 3, 2 and 3, well, between 2 and 3 we have 11 over 16. So 2 is included right here. So this is what we have. Maybe this one, full circle, and then goes to 3. Sorry, just make sure it's on the right position here. So this is open circle because 3 is not included. Okay. Next, we're going to consider between 3 and 4. So between 3 and 4, this is 15 over 16, where 3 is included. So 15 over 16 could be somewhere here. Okay, 3 is included, so full circle, and this one open circle because 4 is not included, yeah. And finally, what we have is 1 for x greater than or equal to 4 until infinity. So what we can have is, we can have right here is 4 full circle, and it will goes on the line here, will go on and on. Okay, right. We can also plot this part. The result here is going to be 0 for x between 0 and between negative infinity and 0. 0 is not included. Therefore, therefore 0 is not included. Open circle, yeah, open circle, and we have this line that is going to go on in this direction. The probability is going to be 0, yeah. So this is how we can represent a distribution function using graph. Okay, now we're going to look at the reverse process. For example, you might be asked to find what is probability mass function when CDF is given, when the distribution function is given. Okay, so what we have done so far is, in this example, we have small f, and you want to find what is big F. And right now we're going to look at the reverse process, where you are given big F and you need to find what is small f. Okay, and in order to do so, this is the result that you can use. Let's say we have random variable x that consists of the following values. So the value here is the smallest, the value here is the largest. So x2 is bigger than x1, but x3 is bigger than x2 and is also bigger than x1. There is a clear ascending order to the values given, yeah. Therefore, if you want to find the probability mass function for the first value of x1, then it can be obtained by simply considering the cumulative distribution function for x1. Okay, if you want to find what is fx2, for example, so if you want to find fx2, so I is equal to 2. Therefore, in order to get this result, you have to find what is the distribution function for x2 xi, I is equal to 2, and you've got to minus the distribution function for x equal to 1, x1, because I minus 1 is I is 2, so 2 minus 1 is 1. So this is the process in order to find probability distribution for x equals to x2. This is what you have to do. And in a similar manner, you can see that if I want to find what is f for x3, therefore I need to find distribution function for x equals to x3, because xi is going to be x3. In this case, I is going to be equal to 3, I is 3, I is 3, and minus the distribution function when we have I3, 3 minus 1 is 2, so we're going to minus with distribution function for x equals to x2. Perhaps this example, perhaps this statement is better illustrated if we look at example. Yeah. Okay. This is an example where you have a distribution function of x. Okay. And here we can see that this statement is also similar to saying that the result here is 0 when x is between negative infinity and 2. Okay, and we can see that when x is 2 or more, the result is 1 over 36, and so on. Therefore, the lowest value of x is 2, and the highest value of x is going to be equal to 12. So that's the highest value of x. Now, this part here can also be written as x greater than or equal to 12 and less than infinity. Okay. So here, I think maybe we can try and approach this by perhaps creating a table if you want. So what we have here, we have the value of x. Okay, we have the value of x. The lowest value of x is 2, so 2, and then we've got 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then from here we can see the result of big F for each x. So here is 1 over 36, okay, between 2 but not included 3, so this is 1 over 36. When it is 3, when it includes 3, now it is 3 over 36, but it doesn't include 4. When it includes 4 now, it's going to be 6 over 36. Okay, I'm just writing down all the results here in a similar manner. And 15, x 21, 26, 30, 33, 35, and here we've got 1, or you can write down 36 over 36. Okay, so that's the result here, and you are required to find probability distribution of this random variable, which is small f. So this is what you need to find. Now let me just demonstrate to you that this one is actually x1, this is x2, this is x3, this is x4 in this manner. Okay, this is xn. Okay, I'm just using the notation given here. Okay, I'm just explaining to you what is the notation here means. So x1, x2, x3, x blah 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 until xn, and clearly you can see that the values here are, for example, this is the lowest value, 3 is bigger than 2, 4 is bigger than 3 and 2, so this is some sort of ascending order, and this value here is of course the largest value. So according to the result given here, if I want to find what is fx1, if I want to find what is fx1, then the result here is just taking the value of cumulative probability for x1. Okay. Right, maybe this is what I'm going to do. I'm just going to use the same table because I'm too lazy to write down x blah blah blah. So I'm just going to consider fx written here. Okay, so for this value here, because this is the value for x1, so I want to find what is fx1 according to the result here. It is equal to fx1. So it is equal to fx1. So this is x1. So this is fx1. So for this one, the result here is going to be the same, which is 1 over 36. Okay. Now, let's move on to this part. What is fx2? Okay, this is x2. And according to what we have seen just now, in order to find fx2, we have to take the value of cumulative probability for x2 minus for x1, cumulative probability for x1. So what it means really, we are going to take this one minus fx1, which means we are going to take, this is x2, which means we're going to take this result minus this result. So this is fx2, this one, x2, minus this one. So 3 over 36 minus 1 over 36 is going to be 2 over 36. Okay. Next, if you want to find fx3, okay, according to the result that I have demonstrated to you just now, now we're going to consider x3, cumulative probability for x3 minus the cumulative probability for x2. So this is x3, so we're going to take this one minus this one. 6 minus 3 is 3 over 36. Now, in a similar manner, I think you get the idea. If I want to find what is fx4, this one, so I have to take this value minus this value. So 10 minus 6 is going to be 4 over 36. Now for this one, I'm going to take 15 minus 10, so it's going to be 5 over 36. So I'm just following the same pattern really. And for this one, I'm going to consider this minus this. So 21 minus 15 is 6. Okay. For this one, we're going to take this value minus this value. So we're going to get 5 over 36. And I'm just going to continue in the same manner for this one. 30 minus 26 is going to be 4 over 36. Okay. And for this one, 33 minus 30, so 33, so 3 over 36. And for this one, I'm going to take this value minus this value, which is going to be 2 over 36. And finally, for this one, we're going to take this guy minus this guy, which is 1 over 36. So there you go. This is what we're looking for. This part right here, which is the result of probability distribution or probability mass function for random variable x. Okay, I think that's all for now. Thank you very much for watching.